Can you see the screen? So write the
Yes.
topic is preparation of alkenes. No, you don't have to write, by the way. You just need to listen. Preparation of preparation of alkenes. So in preparation of alkenes, first of all, we will be having from alkynes okay. So in alkynes we have two different reagents. So you have C, triple bond C, which is bonded to R, let us say dash R1, and this carbon is bonded to R2, some different groups. So there are two reagents. If I add H2 to it, 1 mole of H2. Now it depends what is the condition that I'm giving. So if I do this in the presence of palladium and charcoal, then I am going to get C double bond C, and in this R2 and R1 will be in cis position, and the hydrogen will also be in cis position. So what I will be getting? I will be getting a cis alkene. I hope all of you are familiar with this word cis and trans. Yes or no? Samira, you tell me.
Yes, sir.
Samira, Ishma, Samira and Sara, cis and trans पढ़ा है ना हम लोगों ने?
Yes.
है ना, cis and trans पढ़ा है. So you have same groups here, so that is why this is cis alkene. And if I do the same thing in the presence of sodium in liquid ammonia, sodium in liquid NH3, then I am going to get a trans alkene. Okay, I'm going to get a trans alkene. Simple, yes or no? So I will also give you a reason why this is cis alkene, because you have palladium. This is palladium, charcoal, and in that we have, first of all, we put hydrogen. So hydrogen not attached like this. Now comes C triple bond C. So what happens? The hydrogen, they get attached on from the same side, and that is why you have here. Cis alkene, but in liquid ammonia we have a solution, and it is liquid here. So what does it form? It forms the most stable alkene, that is the trans alkene. It forms most stable alkene, that is the trans alkene. But in palladium charcoal, we don't have any choice. The hydrogen, they are attached over the pi bond from the same side, and that is why we get a cis alkene. Okay, so I'm giving you some reactions. There is just a difference of cis and trans. So here you are going to get cis alkene. So this will be CH3 is bonded to carbon, double bond CH2, and there will be hydrogen here. Okay, like this. Can you write the product, yes or no, guys? Tell me. Otherwise, I will give you some reactions. I will do some reactions in front of you. Do I need to do examples, or you can write the products?
Sir, you can just explain one and then we can do the rest.
ये तो explain किया ना हमने. Okay. So in this, what is, you will have this carbon, है ना? So addition is going to take place. अच्छा, wait a second. I have to also have H2. So hydrogen and hydrogen both will be attached from the same side in this case, and you will be getting carbon, double bond carbon. This hydrogen not present already. This hydrogen is added. This hydrogen is added, and here you have CH3. Now in this case, you have H2, presence of sodium, and liquid ammonia. Now here you have carbon, double bond carbon. This carbon is initially attached with CH2, CH3. Then you will here make a trans group, CH3, and here you have hydrogen and hydrogen. Okay, so write this and let me know if you have any doubt. Then I will give you questions. Write these two, then I will give you questions. Write these two questions. So the pi bond is breaking in the alkyne, and you are forming CH bond on those two carbons where you had the pi bond. The triple bonds are double bond, and then you are adding hydrogen. Done, guys?
Yes, sir.
Okay. So in this case, first of all, you will see it is PD charcoal. So you will write C double bond C Okay. Now cis or trans? Tell me. Cis or
Cis.
trans, guys? Cis. So you will keep them in the same way, and then you will just add hydrogen on the same side. Add hydrogen on the same side. Okay. Now in this case, C double bond C. Now you tell me, cis or trans?
Trans.
Trans. So if you have CS3 this side, let me take here you are having CH. This has CS3 group attached here. This is one more CS3 group attached here. And then transform, then here you will be CS3. Hydrogen will be added here and here. Okay. Can I move on? Yes or no? What will be the name of this compound, guys? What will be the name of this compound? So tell me, functional group? Functional group?
E.
V function.
Alkene.
Unsaturation. E. नहीं. Okay, Shravya is here. Na Shravya को थोड़ा सा दूसरा ही है. Shravya, we use some a bit different way. So you may just see here. Functional group is what, guys?
E.
E. Okay. And what is the unsaturation?
En.
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 What is the parent? What is the parent?
Hex.
कितने टर्मिनल है? How many terminal? A, B और C. Yes or no? Where should I start from? Where should I start from? A, B or C? बताइए. Where should I start from?
C from C.
C na? All of you see. Correct. So what is the parent? 1, 2, 3, 4, 5, right?
5.
Pent. What is the substituent? Only one substituent. Methyl. Only one substituent, that is methyl. Now you tell me, where should I start numbering from? A or C? A or C? Where should I start
C.
numbering from?
C.
C.
C, na? Because we give preference to the double bond. So 1, 2, 3, 4, and 5. So methyl will be in which? Methyl is at 4th place. So this will be 4-methyl. And the En, it is at 2nd carbon. So 2-ene. So this will be 4-methyl. Pent 2-ene. Okay, correct?
Yes, sir.
Okay. Now, so this is how we are going to prepare. This is how we are going to prepare from alkyne. You have two things. You have PD charcoal and sodium in liquid ammonia. Next is from alkyl halides. From alkyl halides. So in alkyl halide, you will have carbon. There will be 2 carbon. You have hydrogen, and in the next case, you have halogen group, that is X. So in alkyl halide, you have CX bond. So you can form alkenes from alkyl halide which have beta hydrogen. Why beta hydrogen? This is alpha carbon, which has the halogen atom. The next atom, next carbon will be beta carbon. That beta carbon should have one hydrogen group. Now what is going to happen? They are going to form HX. That means H will be liberated like this. H will give the bond like this, and X will leave. X will leave like this. And hence there will be a formation of C double bond C. There will be a formation of C double bond C plus we will be getting what? We will be getting HX. We will be getting HX. So hydrogen is leaving, hydrogen is giving the electrons, hydrogen is giving the electrons, and what is happening? X is taking the electron. So here we are forming a bond, and this is happening in the presence of alcoholic KOH. And there will be some heat involved. There will be some heat involved. So in this case, the X, it should be either chlorine, bromine, or iodine. It should be chlorine, bromine, or iodine. Now, let us look at the mechanism. In mechanism, what happens? We have carbon bonds. There is hydrogen, and there is Br. Okay, so let us keep this hydrogen as of now. All of these are hydrogen. So we have alcoholic KOH. So you have OH negative ions because you have KOH. You have OH negative ions, and what is the nature of OH? It is a base. What it does is it will abstract the hydrogen. So it will attack on the hydrogen. So what it is doing? It is making a bond with hydrogen. So when it is making bond with hydrogen, what happens? When it is making bond with hydrogen, hydrogen will break the bond. That is the CC bond, CH bond. Hydrogen will break this bond, and it will transfer the electron towards the carbon atom. Now, as soon as it is transferring the electron towards this bond here, the CC bond, this carbon is making how many bonds? 5 bonds, but the carbon cannot make 5 bonds. That is why it will break. It has a choice. It can break the CH bond or the CBr bond. So it has a choice that it can break the CBr bond because it is a weak bond, and the Br will take up the electron. So OH negative attacks on hydrogen. Hydrogen gives the electron to carbon. So when carbon forms a bond, it cannot form 5 bonds. That is why the Br negative ion leaves. So you will get an intermediate state in which you will have a transition state. Okay, now these blue bonds, okay, I'm writing these blue bonds. These are being formed. Then you have these red ones, these are being broken. This blue one is also being formed. Okay, so electrons are going away like this. So oxygen is attacking on hydrogen. Hydrogen is giving the electron to CC bond, and then the Br is taking electron and it is leaving. So you will be forming carbon double bond, carbon, hydrogen, 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 and hydrogen. So the H which left from here to attack the Br, you will get H plus here. You will have Br negative here. They will form HBr. They will form HBr. Okay. So this is the mechanism how it happens. So this is known as the transition state. How the bonds are broken and formed. This is the transition state. Now, we are breaking the CBr bond. We are breaking the CBr bond. And hence, if I want to talk about the rate of reaction for different alkyl halides, then I can say that it is inversely proportional to, rate is inversely proportional to the strength of the CX bond. If the CX bond is weak, the rate will be very high. So when I talk about the bond strength, we have CX, that is CCl bond, and we have CBr bond, and then we have CI bond. CCl is second period, this is third period, this is second period, this is fourth period, this is second period, and this is fifth period. So obviously CI bond is the most weakest. That means it will be, this is the order for bond strength. Now, when I talk about the reactivity, so if I have RCl, RBr, and Ri, since rate is inversely proportional to bond strength, just reverse the order. This will be the order for rate of reaction. Rate of reaction will be this order. Yeah, this will be the order for rate of reaction. That Ri will be fastest, followed by RBr, followed by RCl, followed by RCl. Now, when we are breaking the CX bond, we are breaking the CX bond, right? So CX bond is broken, and this carbon, it is going to get a positive charge. It is going to get a positive charge. So there is a carbocation which is formed. Now, when I talk about in terms of this carbon, the substrate carbon, the alkyl group. So we were comparing what? Here we were comparing the X part, right? Now we are going to compare the alkyl part, that is R. So the
So
rate
why are
of
we not
reaction.
considering fluorine?
Fluorine is very strong. CF bond is very strong, so it doesn't give this reaction.
Okay, sir.
Okay. Generally, it doesn't give this reaction. That is why. Now, in this case, the rate of reaction when I compare the alkyl groups. Rate of reaction when I compare the alkyl groups, then this carbocation should be stable. If this carbocation is stable, then this reaction can happen faster, and this carbocation then will lead to product. So if I talk about rate of reaction, then 3 degree Rx will be fastest, followed by 2 degree, followed by 1 degree, because 3 degree alkyl halide will give me 3 degree carbocation, which is most stable. And that is why if the carbocation is most stable, then we can move from reactant to intermediate very fastly. And if we are forming reactant very fastly, that means we can, if we are forming the intermediate very fastly, that means we will be able to form the product more easily. We will be able to form the product more easily because neutral to positive. And then when again we are forming the product, it is again neutral, right? So our barrier is this. That means from reactant that is neutral to charged species. So if this is happening faster, the next step is what? The next step is very easy. The next step is already very fast. So this is all about from alkyl halides. What are the products are we going to get? What are the products we are going to get? Okay. Now let us talk about some examples. So if I have CH3 and CH2Br, then in the presence of alcoholic KOH, I am going to get CH2 double bond CH2. Now this hydrogen is going to get eliminated and the HBr, and plus we will be getting HBr. Yes or no? Any problem till here? No problem, right? Yes or no? Hydrogen from here and the Br from here. Correct?
Yes.
Yes, sir.
And HBr. And this will be forming, here we will be forming CH2, CH2 here pe hai, sorry, CH2, CH2, and there is a double bond. But if I have something like this, let us say CH3, then you have CH, here we have Br, here we have CH2, and here we have CH3. In the presence of alcoholic KOH, this is our alpha carbon, this is beta, this is also beta. Yes or no? Yes or no, guys?
Yes, sir.
Now we can form HBr from this carbon also, we can form from that carbon also, correct? Now let us form both the bonds. Let us form from both of them and let us see what is the stability there. What is the stability? So if I go with, let us say that this is the beta 1 and this is the beta 2. So I'm forming from beta 1. I will be getting CH2 double bond CH, CH2, CH3. If I'm forming from beta 2, then I will be getting CH3, CH double bond, CH single bond, CH3. Okay. Now we have got two alkenes. If you remember hyperconjugation, in hyperconjugation we said that Hyperconjugation will give you the stability of carbon free radical, carbocation, and alkenes also. Three things, right? Whatever is sp2. So in this case, if I look at the sp2 carbon atoms, this is sp2. I look at the sp2 carbon atoms. This is sp2. This is sp2. This is the alpha hydrogen here. And alpha hydrogen, it is equal to only 2. In this case, sp2. This is sp2. This is sp2. And these are the alpha hydrogen. This is also the alpha hydrogen. Alpha carbons, and this will be alpha hydrogen. So here you have 3, and here also you have 3. That means we have total alpha hydrogen, which is equal to 6 in this case. And in this case, we only have 2 alpha hydrogens. Yes or no? Yes or no, guys?
Yes, sir.
Yeah. So in this case, which will be A or B? Since B is most stable, B will be the major product. This will be our major product. This will be our major product. Why? Because this is more stable due to more number of alpha hydrogen and hence more hyperconjugating structures. All of you got this? Yes or no? Tell me.
Yes, sir.
Yes. Okay. I will write a statement now. When alkyl halides are treated with alcoholic KOH with some heat, it leads to beta elimination. Beta elimination, why? Because we are eliminating beta hydrogen. That is why beta elimination. It leads to beta elimination and more substituted both the products are actually formed now. So we'll write and HX is eliminated to form alkene. Next point is that more substituted alkene is formed as major product in this reaction. Okay, so more substituted. That means the double bond will have the carbons of double bond, they will have more number of alkyl groups. Carbon, they will have more number of alkyl groups. So I'm giving you some questions. Let us discuss them. Okay. Okay, so first of all, identify the alpha carbon. I'm writing some carbons here. A, B, C, D, and E. Which is the alpha carbon here? Tell me. Which carbon is attached to Br directly? Simple thing, guys. Alpha carbon. The carbon that is attached to functional group. Which carbon?
E.
E.
E, na? Bromine. E. Yes, Sarah?
Yes, sir.
Anna, E. E is our alpha carbon. Okay, then what are the beta carbons? What are the beta carbons? Identify
E.
alpha carbon.
Sorry, A.
Then identify beta carbons. Now check if beta carbon has any hydrogen.
Yes, it has.
Now, if you are taking care, then you will find there are two betas, A and B. Yes or no? Both are beta, no? है कि नहीं? Khalid, This is alpha.
Yes, sir.
This is beta. This is also beta. All of you agree? Yes or no? A
Yes,
and D
sir.
both are beta.
Yes, sir.
Now you tell me, does A have any hydrogen?
Yes, it is. Wait.
Yes,
No,
na?
no, no. A, yeah. A.
Hmm.
Oh, yeah, yeah. That A. Okay, so.
How many hydrogen?
Yeah,
3.
How many
yeah.
hydrogen?
Three.
वाह वाह, क्या है गाइस, आप लोग हाइड्रोजन नहीं पहचान पाएंगे तो कहां से होगा सवाल? What about this carbon? How many hydrogen here, Matthew?
1 hydrogen.
Oh, it's one.
Why one? Matthew बताइए आप, ये तो आपने बस
Because-
जवाब दे दिया. हाँ, tell me
Because-
Matthew, why one?
Sir,
Because there's only one. There's one hydrogen connected to that carbon.
Why one? Why not two? अच्छा यहाँ बताइए Matthew only, okay? What about this carbon? How many hydrogens are there?
One.
Okay, what about this? How many hydrogens here?
There.
Here.
There's one there.
Huh?
One.
One. What about here?
One.
One. What about here?
One.
One. Okay, so that means you are saying we have something structure like this.
Yes. Sir.
sir, I think there is 2
हाँ
hydrogen.
हाँ 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 हाँ. Matthew, you are saying that this is the structure, right? Yes, Matthew. I can't hear you. Sad. Matthew, you're saying this is the structure? Matthew, is this the structure you are saying? Can you please write in chat also, yes or no? Please, all of you write in the chat now. Is this the structure? Are the number of hydrogens correct? Have I assigned the number of hydrogens correctly? All of you write in the chat, yes or no? Okay. Matthew, okay. So Matthew is here, I think. Matthew, can you hear me now?
Yes, sir. Yeah.
So you are saying this is the structure, right?
Yeah.
What was that? Yeah. ऐसे तो lag करता है, आप अपने आप से ही lag करवा रहे हो ऑडियो को. अच्छा देखिए, not a problem. See, अब बताइए, like how many bonds a carbon has? Carbon should form how many bonds? If it is neutral, 4 bonds, right?
Yes.
4 bond, no matter whether it is single, double, जो भी हो मिला जुला के 4 होना चाहिए. Yes or no?
Yes, sir.
Okay. Now in bond line structure, what happens? Now in bond line structure, what happens? This is our carbon. This carbon. Yes.
Yes.
Right, Matthew?
Yeah. Yes.
So
yes.
how many bonds is it making? How many bonds? This carbon is making how many bonds now? How many bonds
3.
can you see? 3.
3.
So you will just add one more bond, and that will be satisfied by hydrogen. Okay.
Yes, sir.
Okay. So 1 hydrogen. And here, tell me how many bond is it making?
Visibly 2.
Visibly 2. So how many hydrogens should I add to make it 4?
2.
आया? समझ में आया आपको?
Yes, sir.
Now you tell me. If I have CS3, then this carbon has how many hydrogen? देखिए ऐसे 4 minus visible bonds is the number of hydrogens. So tell me 4 minus how many visible bonds are there for this carbon?
3.
So 4 minus 3, 1 hydrogen will be there.
All right.
आ गया?
Yes, sir.
इसीलिए कर लेते हैं आप ऑर्गेनिक केमिस्ट्री हमारे साथ, है ना? कर लेना चाहिए था आपको. So A also has hydrogen and B also has hydrogen. All of you guys, yes or no? So I can make two products. Either I will be having a double bond between A and B, and alpha beta के बीच में double bond. You will have double bond between alpha and beta. So between A and E, or we will also get, we will also get a product which is having a double bond between A and D. Yes or no? First of all, tell me that. है ना? अरे hydrogen and hydrogen are here. So either HBr will be made by this A and D, or the HBr will be made by A and E. Yes or no, guys?
Yes, sir.
No problem, na? What about others? Hamza, Hiba, Khalid, Salman.
Yes, sir.
No problem with this product.
No,
No,
sir.
sir.
Now tell me which will be major, A or B? Which will be major? चलिए sp2 कार्बन बताइए, है ना? Is this sp2? Is this sp2? स्टेबिलिटी ऑफ एल्कीन, गाइस क्या हो गया? आप लोग जवाब ही नहीं दे रहे हैं आजकल. हाइब्रिडाइजेशन वगैरह चैप्टर 4 से पढ़ाया जा रहा है. देखिए अब बताइए sp2 sp3 sp क्या है यहाँ पे? दिस कार्बन एटम.
sp3.
ओके गुड, ठीक है. प्लस बस इसे याद कर लीजिए ना, ऐसे देख के आ जाना चाहिए आप लोग. व्हाट अबाउट दिस कार्बन?
sp2
sp2. व्हाट अबाउट दिस कार्बन?
sp2
sp2.
Both of these are sp2. So this is now my alpha carbon for the alkene, and this carbon is also alpha carbon. So here we have 2 hydrogens, here we have 3 hydrogens. The number of alpha hydrogen will be equal to how much? 5. In this case, this is our alpha, this is sp2, this is sp2. So these are our alpha carbons. Here we have 2 hydrogens, here we have only 1 hydrogen, right? So here the alpha hydrogen will be equal to 3. So which will be major now? Tell me, A or B?
A.
A will be major. एक और चीज देखिए आप लोग, है ना? उतना आप लोगों को नहीं देखना है अगर, है ना? You can see one more thing. Look at the double bond. Okay, look at the double bond. So this has how many carbon attached to it? The double bond has how many carbon attached to it? अरे बताइए भाई. This is the double bond ना. So ये carbon attached है यहाँ पे, ये carbon attached है यहाँ पे, और this is double bond से ये carbon attached है. So total number of substituent is how many? 1, 2, 3. It has total 3 substituents. If I talk about this double bond, this is one of the substituent, this is one of the substituent, only 2 substituent. So this is more substituted. That is why I have written more substituted alkene is formed as major product. You got this? The double bonded carbon atoms, if they are attached to more number of carbons, that will give me the major product. All of you got this? Yes or no? नहीं तो फिर हाइपर कॉन्जुगेशन है, उसी से देख लीजिएगा. अल्फा हाइड्रोजन मेजर एंड माइनर. इसमें टाइम चला गया आप लोगों का. देखिए एक तो आपका कहाँ से बन जाएगा प्रोडक्ट, यू विल हैव दिस इज द अल्फा कार्बन है ना, दिस इज द बीटा कार्बन, this is the beta carbon or this is the beta carbon, but this beta and this beta are same, that is why I will just write there is only one beta carbon, that is the CH3. So you can either make alpha beta double bond like this, CH2 double bond, there will be a CH3 here and you will have CH3 here, so alpha beta double bond, Br will be removed, or you can make alpha beta double bond between these two, Br will be removed here also, Br is removed here also. Here also we have CH3. This is CH3. This is CH3. So now you tell me A or B. Major product कौन सा होगा? देख के बताइए. More substitution. Where is more substitution? Look and tell where is more substitution. Okay, Shravya. What about others? Hamza, Hiba, Khalid. Look at the double bond. है ना, बस double bond में देखिए and then look the next carbon है ना, where you have more number of carbon atoms attached to the double bond, more number of carbon directly attached to the double bond. Okay, please remember directly attached to the double bond, more number of alkyl groups directly attached to the, listen, turn the mic on guys, all of you, turn the mic on, turn the mic on, इतना टाइम नहीं लगता है. ओके सारा, ओके फाइन, अब आ रहा है आंसर आप लोगों का, अब आ रहा है. स्टिल वेटिंग फॉर गाइस. खालिद, मैथ्यू, सलमान, समायरा का नहीं आया आंसर, जैनब, हिबा,
Sir, A?
इश्मा. अरे यहाँ सब दे रहे हैं जवाब आपको चैट में दीजिए जवाब. हाँ, माइक ऑन कीजिए, टर्न दी माइक ऑन, एक्सेप्ट हमजा, सारा एंड श्राव्या, टर्न दी माइक ऑन ऑल ऑफ यू. टर्न दी माइक ऑन. अरे माइक ऑन करने बोला, माइक नहीं ऑन कर रहे, आंसर दे रहे हैं. माइक ऑन कीजिए ऑल ऑफ यू. आई डोंट हैव टाइम, टाइम नहीं है टाइम. समायरा इज ऑन, अदर्स, हिश्मा, Khalid, Zainab is on. Okay, fine. Thank you. Now you tell me, in A, a double bond is formed between how many carbons? A double bond is formed between how many carbons?
Two carbon.
Two carbons, all of you.
Yes, sir.
Okay. So in the A structure, you identify both of those two carbon atoms, है ना? I hope you have identified this carbon and this carbon. Yes or no?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
This carbon. Okay. So just let me change this highlighting part so that I can refer it as red and green. Now tell me, the green carbon is attached to how many carbon atoms? The green carbon is attached to how many alkyl groups? Is it attached to any other alkyl group?
No.
The green carbon?
No.
No, na?
No.
No. Now you tell me, the red carbon, it is attached to how many alkyl groups?
Two alkyl groups.
All of you agree? कहाँ गई समायरा, इश्मा, जैनब? आंसर क्यों नहीं दे रहे आप लोग? So here the substitution is how much? 2. Now you tell me, identify those two carbon atoms which have double bond and tell me how many substituents is there. They are having, they're attached to how many carbon atoms directly? The red and green here also. In total, tell me.
Green is attached to 1 and red is attached to 2.
So how many substituents in total? How many alkyl? 3. So B will be major. ठीक है? All of you?
Yes.
Okay. Fine. But the best method is to go with sp2 and then check the hybridization and all. Okay. Now let us do another from vicinal dihalide. Have you heard of this word vicinity? Have you heard of this word vicinity? No. So let me tell you. Vicinal is derived from vicinity. अरे दिखाई नहीं जा रहा हमसे, क्या हो गया? Vicinity. Vicinity means in neighborhood, near. Okay. Vicinity means neighborhood, near. तो अगर आप लोग इंग्लिश में ज्यादा मार्क्स लेके आना है तो he lives in my neighborhood लिखने से अच्छा he lives in my vicinity, है ना? He lives in my vicinity. And vicinal dihalide means you have a carbon atom, another carbon atom. Both of them are the adjacent carbons. They have X. Adjacent carbon. They have the halogen. That is X halogen. That is X. And simply, if you react this. If you react this with zinc, then you form a double bond between those two carbons, plus you get Zn X2. You get zinc halide. Okay, you get zinc halide. So this is one reaction. So let me write some questions. This is easy. Okay, this is easy. Write the products. You have Br and Br. You react this with zinc. So you identify that there is vicinal dihalide. And you just form a double bond between them and you remove the zinc and Br2 like this. Okay. So I hope this is easy for you guys. Not much of a problem here. You have Br and Br plus zinc. Then again, same cyclopentane, a double bond between those two carbon atoms which had Br plus zinc Br2. If you have Br here and if you have Br here plus zinc, then you will be forming a double bond here. That means CH2 double bond, CH2. Plus you will be getting zinc Br2. Plus you will be getting zinc Br2. Any problem here? Easy? Yes or no? Very easy?
Yes,
Yeah.
sir.
Yes, sir.
Very easy. Yes. Now write the last one. No, don't write. By acidic dehydration. Hydration of alcohol. Now, in this case, this is very similar to it is very similar to what we did with alkyl halides. We need alcohols with the alpha hydrogen. It should have H. And then when we react this with some heat and H2SO4, then we are forming, water will be removed and you will be forming a C double bond C. Water will be removed and you will be forming C double bond C. Okay. So you form alkene from alcohol and those alcohols should have a beta hydrogen. It should have a beta hydrogen. Okay. That means if I use CH3, CH2, CH2, OH with some heat and H2SO4, then what I will be getting? I will be getting CH3, single bond, CH, hydrogen will be removed from here, and OH will be removed from here. CH, double bond, CH2. Okay, easy, right? This is easy. This is asan. But I will talk about the mechanism here also. And you will see a similar kind of trend as we saw in the alkyl halide. And when we did the elimination reaction in alkyl halide and the elimination reaction in the alcohol also, it is very similar. So we'll discuss that in the next class. As of now,